Welcome to the second part of this FMEA video series. In the first part, we have discussed about the basics of failure modes and the calculation of RPN. And in second part, we will discuss about the second topic, that is FMEA worksheet. So this FMEA worksheet is generally an Excel sheet which is used to compile all the information used for the FMEA process and the investigations and the decisions of FMEA. So it mainly involves the component functions which are present in the system, the failure modes which we identify regarding the function and components, the root cause of the failure, the impact of this failure, and using this impact, root cause, and failure mode, we calculate the severity, frequency, and detection, and the RPN of these failure modes. Once the RPN is calculated, we check if the corrective measures are needed for that particular failure mode. And if needed, the corrective measures are implemented. After the implementation of corrective measures, we check whether the new SFD and RPN are within acceptable limits. And once the RPN is in acceptable limit and SFD are in their respective acceptable limits, we say that okay, the design is now complete and the development can begin. So basically, this was the short form of the FMEA actual worksheet. This is just to make you understand what are the components of a FMEA worksheet. We'll discuss this FMEA in detail and we will use an example to understand and implement this FMEA. The examples which we will be considering is an imaginary automatic sliding door system, and we will apply this FMEA worksheet on this system. So before performing FMEA on any product or component system, it is very much important to have a detailed understanding of the system so that we can identify the failure modes. So let us have a look about the product or system which we are going to use for this FMEA. So this is an automatic sliding door system, and the purpose of this product is to detect moving people and open or close the door accordingly. When the people approach to the door should be open, and when they cross the door should be closed. The components of the system is the first one is the sensor, which will detect the moving objects and people. The second is the sensor, which will detect if there any object in between the doors, so that the doors, while closing, do not collide with any people or object. The third component is the motor belt and pulley system, which will be used to rotate the doors when they are about to be opened or closed or moved in horizontally. And the fourth one is the controller, which will take input from the sensor and then give the output to the motor when it should be operated. So, uh, with these basic components in mind, we will use FMEA worksheet to apply FME to this system. So, in order to do FMEA worksheet on sliding door system, we will divide the FMEA worksheet in two parts. The first part is then highlighted in blue and the second in orange. The blue part mainly covers with the components, the identification of failure modes, the root cause and impact of the failure. Once the blue part is completely filled, we will check the SFP and RPN of each of the failure modes, and then we will decide accordingly if the corrective measures are needed or not. This we will be doing to simplify the work and focus on the uh, main areas of the work according. Let us start with the blue part and we will try to fill the component failure, root cause and impact for this automatic sliding door system. So the first point which we can see here is about the sensors. Putting it on the first row, that the object detection sensor. It can have two failure modes, like when the sensor is not able to detect the object, or even in case when the object is not there, it is detecting that something is there and opening the doors. So both these are the events or scenarios in which the door's performance will degrade or it will not behave as intended. And if we check for the root cause of these failures, the object not detected uh, can be due to the uh, sensor failures due to short circuit or open circuit. That is, there is some problem in the circuit and the signals are either always sent as 1 or it is always sent as 0. And the impact of this failure can be that people can collide with the door as it is not opening it, and people will expect that the door should open as they approach. And the second is that door will not be operational. People will have to take some other path. For the second failure mode, that is the false detection of the object. The object detection logic may not be working, or there can be again some sort of circuit failures like the open circuit and short circuit. And in both the cases, the unnecessary opening and closing of the door and extra power consumption will occur. So, for this first object, the object detection sensor, these two are the failure modes which we have identified for now. These are the root cause, and this is the impact. Regarding the obstacle detection sensor, which we have placed to detect the objects in between the doors, again, we can have the same failures, that is, object not detected or the false detection of objects. And the root cause will remain same, that is the short circuit and open circuit, or the logic is not working. And in both the cases, the impact will be like the collision of the people with the door or unnecessary opening and closing of the door, power consumption. So these are the failure modes for the second object, that is obstacle detection sensor. Now moving to the third point, that is the motor. What basically we can see is if the motor is not able to rotate, even if my controller gives the signal to open the door, since the motor is having failure, the door won't get open. So the motor not able to rotate is a failure mode. This can occur when there is a internal failure of the motor, either mechanical or electrical. And again, the impact will be that the door cannot be opened and closed. So these 3 points we have identified for the three components. And moving to the fourth part, that is the controller. So the failure mode can be that if there is any software bug in the controller and during the use, during the runtime, there is an error. So again, the door cannot be opened or closed. So again, this failure mode of the controller will have same impact which the motor was having, but the failure modes are different for respective components. So we have written it in the next row just to cater that this is related to the controller. Moving to the next part. The next part is pulley belt. And if the pulley is not able to rotate the belt, so for example, if the system is being used for years and the belt has gone loose and it is not fit with the pulley size, then the belt may slip or the belt may be not able to rotate the pulley, and again the door won't be able to operate. So this was the first part for FMEA worksheet. Here we have identified the failure modes which can occur in the system and in which component the failure modes can occur, what are the root cause, and what can be the impact on the system and the user. So after completing the first part, we will move to the second part, that is the severity, frequency, and detection for all these identified failure modes in the RPN calculation. We will check if this SFT and RPN are acceptable or is there any countermeasure needed. And if the countermeasure is needed, we will apply the countermeasures. And again, we will check if the new SFT and RPN is acceptable. Until this new SFT and RPN are accepted, we will continue to apply corrective measures and bring the SFNT and RPN down. So this was about the first part of FMEA worksheet, the identification of the component failure modes, root cause and impact. Regarding the SFT and RPN calculation, we will check them in the next video. Thank you.